Imagine a bridge so ambitious, so audacious, it could redefine a nation's infrastructure and connect two historically separated lands. That's the dream behind Italy's renewed push to build a bridge across the Strait of Messina, linking Sicily to the mainland. But will this colossal project actually work? Or is it destined to become another expensive, unrealized vision? The Italian government has recently given the go-ahead for construction to commence on what they boldly claim will be the world's longest single-span suspension bridge. This isn't just a bridge, it's a statement. Dubbed the Strait of Messina Bridge, this engineering marvel aims to span the 2-mile stretch separating Sicily from the rest of Italy. The estimated price tag? A staggering 13.5 billion euros, approximately 15.7 billion USD. The Italian presidency of the Council of Ministers assures that this monumental sum will be entirely publicly funded, with allocations already earmarked in the 2024 and 2025 budgets. But here's where it gets controversial. Is this the best use of public funds? Especially considering Italy's existing infrastructure needs. Believe it or not, the idea of this bridge isn't new. The project was initially approved way back in 1971. However, it has faced numerous cancellations over the years, primarily due to financial concerns and questions about its practicality. The project was revised in 2022, breathing new life into the ambitious plan. Current projections anticipate construction starting in May 2026, with completion slated for 2032. That's a long time. A lot can happen in 6 years. Pietro Cellini, CEO of Webuild, one of the key companies involved in the construction, expressed his enthusiasm, stating that the approval marks the start of a new season of vision, courage, and confidence in the capabilities of Italian industry and the entire infrastructure sector. He believes the project will be a source of pride for the nation. But is this optimism justified? So how feasible is this grand design really? The Strait of Messina is located in a region known for its seismic activity. This raises serious concerns about the bridge's structural integrity. And this is the part most people miss. It's not just about building a bridge that can withstand an earthquake. It's about building one that can withstand repeated earthquakes over its entire lifespan. However, Lamia Amla, a structural engineering researcher at Toronto Metropolitan University, offers a more optimistic perspective. She points out that other countries in earthquake-prone regions have successfully built major bridges. Japan, for example, is renowned for its expertise in bridge construction, with the Akashi Kaikyo Bridge standing as a testament to their capabilities. Similarly, Turkey boasts the 1915 Çanakkale Bridge, currently the world's longest suspension bridge. These examples demonstrate that building bridges in seismically active areas is possible, but it requires meticulous planning and execution. The risk doesn't go away, but it can be managed, Amlay emphasizes. It just needs to be taken seriously throughout the design and construction process, throughout the bridge's life cycle. This highlights the importance of ongoing monitoring and maintenance to ensure the bridge's long-term safety and stability. Amlay suggests that using fiber-reinforced polymers in certain components could reduce the bridge's weight and enhance its resistance to corrosion. Additionally, specialized expansion joints could help absorb seismic activity and manage the heat generated by the bridge's movement. It's not just about strength. It's about how they perform over decades, she wisely notes. Durability is key, but what else could go wrong? Earthquakes aren't the only challenge. Builders must also contend with strong winds and the corrosive effects of salt water. With the salty air, materials will degrade faster, so durability and maintenance have to be built into the plan, Amlay cautions. This underscores the need for robust materials and a comprehensive maintenance strategy to combat corrosion and ensure the bridge's longevity. Webuild asserts that they have subjected the construction materials to rigorous testing, confirming their ability to withstand wind speeds of up to 181 miles per hour. They also claim that wind speeds in the area have never exceeded 89 miles per hour. While this provides some reassurance, it's crucial to consider the potential for extreme weather events in the future, especially in light of climate change. And that's not all. Resistance from local residents is another significant hurdle. A movement called No Ponte, Italian for no bridge, has emerged, with opponents arguing that the substantial funding should be directed towards improving existing infrastructure projects that are in dire need of attention. This raises a fundamental question. Should Italy prioritize building a new landmark or focus on repairing and upgrading its existing infrastructure? The project has already experienced numerous delays and setbacks, including multiple cancellations, revisions, and lengthy periods between major milestones. This history of instability raises concerns about the project's long-term viability. Webuild emphasizes that the site was deemed sound and stable in the most recent environmental impact assessment, which is mandatory for major developments in the European Union. This report evaluates the potential impact of the project on various aspects, including people, cultural heritage, land, soil, and water. The company claims that the newest report incorporates more protections for surrounding rivers and includes plans for reforestation, addressing some of the environmental concerns raised in the past. But are these measures sufficient to mitigate the potential environmental impact of such a large-scale project? AMLET estimates that a bridge of this magnitude could take 8 to 10 years to build if everything goes smoothly, and 15 years or more if unforeseen challenges arise. This highlights the inherent uncertainty and potential for delays in such a complex undertaking. So, what could go right? If the bridge is successfully completed, it could bring significant economic benefits to southern Italy. Webuild estimates that approximately 40% of the project's cost will be allocated to construction, creating over 100,000 jobs. The remaining funds will be used to build new roads, train stations, shops, and restaurants, as well as to redevelop old parks, quarries, and areas affected by coastal erosion. This suggests that the bridge could serve as a catalyst for broader economic development in the region. Currently, a ferry service operates between Messina in Sicily and Reggio Calabria on the mainland. The bridge is designed to accommodate 3 lanes of vehicular traffic in each direction, as well as train tracks. Webuild claims that it could handle up to 200 trains per day and 6,000 vehicles per hour, significantly improving transportation efficiency between Sicily and the rest of Italy. This could boost tourism, trade, and overall economic activity. Ultimately, the Strait of Messina Bridge represents a bold vision with the potential to transform southern Italy. However, it also faces significant challenges, including seismic activity, environmental concerns, local opposition, and a history of delays and setbacks. Whether this ambitious project will succeed remains to be seen. What do you think? Is the potential reward worth the risk? Should Italy prioritize this grand project or focus on improving its existing infrastructure? Share your thoughts in the comments below.